Give me LCOS.
LCOS safe.
Give me TFD.
Only BDU safe.
Give me Papa.
Papa safe.
Give me Nav.
Nav selected.
Edwards Air Force Base, June 1986. Pilots in the Advanced Fighter Technology Integration Program, AFTI, began operational tests of an avionics system of the future. This, the Voice Interactive System. Its purpose, give the pilot an effective new tool for managing the aircraft. This integrates the most advanced avionics with the simplest of all control elements, the human voice. Major John Howard is one of 3 test pilots who have flown with integrated voice over many months under all kinds of conditions.
A lot of things that a pilot needs to access, he can do hands-on. Some of the critical items like changing certain displays and weapons deliveries, those actual things can access hands-on, but there's a multitude of things that he cannot access hands-on, that he has to reach to other parts of the cockpit or look in the cockpit in order to do those type of things.
Just 2 years ago, a system as reliable, comprehensive, and friendly as this would not have been possible. But speech technology applied to avionics has come a long way, very quickly. A lot of those advances have been made here, where much of the basic technology for this was developed, the laboratories of Texas Instruments in Dallas. The head of the research team and noted authority in speech processing, Dr. George Doddington.
This voice interactive system then combines the speech expertise in technology with the basic systems development and the semiconductor digital signal processor development that took place in the semiconductor group and our data systems group with the military systems expertise required to package a military product. This voice interactive system provides, it's a programmable speech processor, so it provides whatever programs, whatever capabilities are programmed into the processor. Now that includes, as a reality, speech synthesis, speech coding, and speech recognition.
The performance of this was proven in tests conducted under strict guidance of the Aeronautical Medical Research Laboratory at Wright-Patterson Air Force Base. The tests were performed in a simulated F16 environment, including jet engine noise and oxygen mask breath noise. Results for all 5 test participants were consistent. The best subject experienced 100% recognition, and the average was 98.41%. An impressive showing, especially when compared to button pushing, where Air Force figures show an accuracy of 93%. Pilot-to-pilot communication is accurate just 80% of the time. At Edwards, former Air Force fighter pilot Bland Smith, now a test pilot for General Dynamics, was one of the first to fly with this.
With all the information coming in, with all the weapons that are available, with all the new avionics, time is becoming very critical to the fighter pilot. It's always been critical, but it's even more critical now with the advances in technology. So any way in which we can make the cockpit easier to manage, easier to operate by saving time is a distinct advantage to the pilots. A voice system has time advantages. I've noted on several instances these time advantages. One instance that comes to mind has to do with the multifunction displays. In order to activate a switch on a particular display, it may require going through several menu pages in order to find that page and then activate the switch. With the voice system, with one phrase, we can do the same job and take much less time in doing that, not to mention the concentration that's required to come inside, look at the multifunction display, go through the menus to find the correct one and then activate the switch.
Give me BDU.
This doesn't change the way a pilot operates the aircraft. Instead,
Eater.
it is integrated into the present
Eater
bus
safe.
design of the cockpit.
Give me Lima.
Smart software
Only
in the
Papa
VIS
safe.
allows it to monitor
Give me
and interact naturally with aircraft
Nav
systems
selected.
and displays. The fire control computer, flight control system, stores
Alpha.
management set, DSys,
Alpha
communication system, and multifunction
Weapon
display
Papa.
are all capable of operating in a
Papa safe.
management by voice mode.
Give me BDU.
BDU safe.
Azimuth, 30, range, 40.
Major John Howard in the AFTI F16.
And at the steer point.
The task,
Steer point.
simulated air-to-air tracking used in close formation flying. The task was run with voice and without. Results? The pilot experienced little difference in range variation, but average tracking error was 40 to 50 mils without voice and only 10 to 15 mils using it. And without voice, the greatest deviation was 100 mils.
Return.
With voice, just 70.
BDU.
No weapons.
Typical thing you have to do is fly through the weather on the wing of another airplane. And in close proximity to another airplane like that, you don't want to take your eyes off of that guy. And then when you're doing something very simple like changing a radio channel, that's a hazardous type thing when you're in such close environment to another airplane. So what voice allows you to do, instead of having to look into the cockpit and try to do this hazardous radio channel change, is it allows you to just simply access it with voice without ever having to take your eyes off the other airplane. In a combat type environment, typical example might be close air support, where you're out having to listen to what the folks either on the ground or in other aircraft are giving you about what target to attack. And they're giving you coordinates, they're giving you bearings, distance, and those type of things. Typically a pilot nowadays has to look in the cockpit and type those things in. And he's already forced down to very low altitude because of the threats that are around there, so that becomes very hazardous. And being able to do that with voice, to speak the coordinates and having to type those in, that's a much safer thing for a pilot to do.
Another veteran pilot who flew VIS at Edwards, Major Mark Steuben.
Coming from the F4 into the F16, I've seen great strides in the mechanization of push buttons and the way the cockpit's laid out and the pilot-vehicle interface. So, especially in the later models of the F16, the CD, I haven't seen that much of a problem with actually pushing the buttons or manually changing the radio channels. Things now that we've brought everything up-front controls or critical weapons type mechanizations are done hands-on on the stick and throttle. So I think push buttons have definitely gotten better and easier to use. On the other hand, there is definitely use for voice on certain things, and I think that's one of our challenges here at the test force, is to find out what we can best mechanize with voice. Not only what can we mechanize with voice, but what is the best utilization of voice itself.
These charts show the combined recognition rate of the 3 pilots in 14 flights conducted from 27 June to 9 September 1986. Their average, 92.1%, includes learning curves of initial flights and the impact of G-forces up to 7 Gs. In this time, Major Howard scored a low of 93.4 and high of 99.1%. All the tasks were built around missions the F-16 was designed to fly, including ingress-egress, close air support, interdiction, close formation flying, and in-flight refueling. Major John Howard, his mission, ingress to target in a low-level nav run over moderate terrain.
Destination, 1, 2, enter, return. That looks like it's in the right place.
Major Howard flew the mission first with voice and later without it.
The first run I made was with voice. I had just enough time to do all the tasks that were required on the first leg, and then I finished the second leg tasks early. The second run, however, was done without voice. I didn't have time to do all the tasks on the first leg and got some of the tasks actually out of order. Work on the keyboard was actually particularly difficult. The average deviation that I had in airspeed and altitude was more than double what it was when I did the voice run.
There are certainly some things that can be mechanized through voice that would be a definite asset in a high-threat environment where you're looking at the target, you don't want to come back inside the cockpit and check a parameter. And certainly like in an air-to-air engagement where you've got an adversary up here and you're padlocked on him, then you wouldn't want to come back in to check certain parameters. And they can be very crucial parameters like altitude or airspeed or your fuel status. And so if you can verbally request this from the airplane and have it give it back to you, audio feedback on, say, your fuel status, then you don't have to take your eyes off of your adversary, and you can find out if you've got enough fuel to engage him or if you need to go home.
Well, I've had pretty good success with the system, and because of the success rate that I've had, it's my preferred method of doing certain cockpit tasks. So I use it routinely in the things that I do.
Set steer point 11, enter.
Steer point 1.
Natural and reliable. Advanced speech technology has
Set
proven to be an
destination 12,
effective new
enter.
tool to manage today's high-performance fighter. On operational
SMS.
missions, it gives the pilot a new level of efficiency and safety.
Display
In the
inventory.
battle space of tomorrow, management by speech may provide the winning edge.
North.
Integrated into the cockpit, speech technology is a natural link to avionics suites of today,
West.
while paving the way for the
117,
complex
01,
avionics and weapon
00,
systems
enter.
of the future.
3200, enter. Return. Go frequency 358.4, enter.
Frequency 358.40.